Hey everyone, and welcome back again to PTV Lidex Education. We continue with our session of answering some typical questions of advanced level physics, June 2023, paper 2. And right now we are going to answer this very beautiful question on capacitors. So it says, as you can find on the screen, some electrical components are connected together in a circuit energized by a 3-volt battery. Right, this is a circuit energized by the 3-volt battery as shown in figure 2. The capacitors are initially on charge. The contact point Z of the switch is closed at point X, Z closed at X, until the 100 microfarad capacitor is fully charged. When Z is now moved to make contact with Y, determine A, the initial current in the circuit, and B, the maximum charge that will be stored in the 150 microfarad capacitor. Okay, the first part of the question says that we should determine the initial current in the circuit. So what happens here is that Z is moved to X and the capacitor charges, right? It charges across the 3-volt battery. Let's call this resistor R, this capacitor C1, and call this one C2. So when we move Z to X, C2 charges across the 3-volt battery until full charge. At full charge, the PD across C2 is 3 volts. Is a PD of the cell. Now, when C2 is fully charged, Z is moved from X back to Y or to Y. At Y, C2 discharges. So here we have the discharging circuit. C2 discharges across C1 and R. So at any instant, right, when we move Z to Y, at any instant, the PD across C2 is the same as the PD across R plus C1. So we say that for discharge, PD across C2 equals to PD across R plus PD across C1. Now we are asked for the current at the start. So at the start of the discharge, at the start T equals to 0, C1 is still on charge, right? At the start of the discharge, C1 is still on charge. On charge means we are saying that Q for C1 is 0. And when the charge is 0, it means that the PD across C1, is also 0. So from there we have PD across C2 equals to PD across R plus 0. And therefore, PD across the resistor is PD across C2, which is 3 volts. So at the start of the discharge, PD across C2 is 3 volts, PD across C1 is 0, and PD across R is 3 volts. So the initial current I in the circuit by Ohm's law applied to the resistor is PD across the resistor all over the resistance, which is 3 volts divided by 1.5 times 10 to the 3, and that will give us 2.0 milliampere. So that's the initial current in the circuit. Then the second part says that we should determine the maximum charge which can be stored in C1. So what we need to understand here is that when the charges as C1 is charging, right, the charge on it is increasing. At maximum charge, the current in the circuit becomes 0. Right? So we say that at Q max, the charge Q is constant, meaning that the current, which is the rate of flow of charge, is 0. And when the current is 0, Q is conserved. Right? The total charge in the circuit is conserved, meaning that the total initial charge is equal to the total final charge between C1 and C2. So there we have that C1 V1 initial plus C2 V2 initial equals C1 V final plus C2 V final. You should know that when the current becomes zero, these two capacitors are in parallel, and when they are in parallel, the final PT across them becomes equal. So that's why here we have V final, V final. So from there we solve for V final. V final is C1 V1 initial plus C2 V2 initial divided by C1 plus C2. C1, right? Simplifying that, we are going to have V final equals C1 is 150, V1, the initial PT across C1 is 0, C2, 100 microfarad, initial PT is 3, divided by 150 plus 100, and that gives us nothing other than 1.2 volts. So that is the final PT across both capacitors. From there, the maximum charge, Q max in C1, right, the 150 microfarad, is given as C1 times the maximum EMF. So we have 150 times 10 to the negative 6 times maximum PT is 1.2 volts, and that gives us 180 microcoulomb. So that is the maximum charge that can be acquired by C1 during the discharging process, and that occurs when the PT across it is 1.2 volts. So that brings us to the end of this wonderful exercise on capacitors. I hope you had a great understanding. We invite you to follow us on our Facebook page, on our YouTube channel, PTV Education. And for those that have not yet subscribed, please kindly subscribe and like the video. Share the video with your friends, because more and more is coming from PTV Education. Bye bye.